Let's just take a minute and look at why, whenever you have a parabola, the residual plot is not going to look linear. So imagine that it's hard to sell lemonade on cold days, easy to sell it on warm days, and hard to sell it on very hot days, probably because no one leaves their house. Let's take a look at this equation. Take a look at your scatter plot as the temperature and the revenue of your lemonade stand, and then take a look at the line of best fit that we're using in order to make predictions about this. Let's take a look. Now, remember I said whenever you're doing your residual plot, basically what you're doing is you're taking this axis and you're kind of tilting it to make this look like the line y equals 0. If you notice, you're going to have a whole bunch of residuals below, a cluster above, and then a whole bunch below again. So notice that's what's happening over here. Your residuals are forming a pattern, and this is basically telling you that the model represented by the line is terrible. The predictions would be way off. Look at my residuals. My predictions are going to be way too low, a lot of predictions too high, and many way too low over here. I don't have any predictions that are accurate. So if your model is way off, as in the example above, your predictions are pretty much going to be worthless, and you're going to notice a very low R squared value, like 0.027, which we'll talk about what that means in a few minutes. Now, sometimes the plot looks linear, but the residual plot doesn't necessarily indicate that it is. Sometimes you can fit a line to the data, but then when you look at the residuals, you'll notice that they're sort of forming a pattern. So if you take a look here, the line actually looks pretty accurate. But if we take a look at the residuals, notice I have a lot above, a lot below, and then a lot above over here. You can tell that there's a bit of a pattern here. And so the line might not be the best fit for the data. Now, does that matter? It's up to you. If you're getting a quick understanding of the relationship, then maybe a line is probably a decent approximation. If you're going to use this model for prediction and not explanation, the most accurate possible model would probably account for that curve. So that would probably be okay as long as you have a model that's very accurate. So just be aware of that as you're looking at your residual plots. So how can you do the residual plots on your graphing calculator? It will actually graph them for you so that you'll be able to tell whether or not a line is linear. So you're going to go to Stat, Edit, put your data into List 1 and into List 2. Then you're going to press Second, Stat, and then you're going to go down to number 7 where it says Resid. Now press Enter twice and then press Enter again. Your residuals are now going to be listed in line 3, okay? Now, when you plot it, you're going to go to plot 1, you're going to highlight the scatter plot, and you'll notice it's automatically going to put X as your list 1 and Y as your list 2. So you're going to need to change your Y list to be list 3 instead of having it as list 2. And that's because we put our residuals into list 3. So it will say list 2, but you're going to want to put list 3. Hit graph and then hit zoom 9 to get your correct viewing window, and notice I have my residuals above and below my line. Now, we're going to talk about the standard deviation of the residuals. So what exactly does that mean? Remember the residuals, if you have a residual that is above the line, that means that it's a positive residual and it's going to the line is going to underpredict the data point. If you have a residual that is below the line, it has a negative value and the line will overpredict your information. So we want to kind of see, like, what is the average overprediction or underprediction? Well, using these residuals, we're going to estimate what is the typical or what's our prediction error by using our standard deviation of our residuals. So if we use a least squares regression line to predict the values of a response variable y from an explanatory variable x, let's talk about what the standard deviation of the residuals are. Now, you do not need to memorize this formula. This is just where it comes from. So remember, your residuals are always going to be your observed value minus your predicted value. And notice here we're squaring that, and then we're dividing it by n minus 2, okay, in the very, very end. So basically you would take every observed value, subtract it from every predicted value, square it, add that to the next one, square it, add that to the next one, and keep going. Add the sum of that, divide by n minus 2, okay, because we have two variables, our independent and our dependent, our explanatory and response variable, and then take the square root of it. But like I said, you're never going to have to do this. Your calculator will do this for you. Minitab output will do this for you. Just understand where it comes from. So this value gives the approximate typical prediction error. So basically what your standard deviation of your residuals tells us is, on average, how far away are the observed values from the least squares regression line or your line of best fit or your predicted value. So basically, if you think about it, if we're taking a look at a graph, okay, and we have residuals above, below, okay, the standard deviation of the residuals is, on average, how far are these residuals from the line?